Good evening, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Synchronization and Migration between ALM Tools, the Value Propositions. Our guest speaker today is Somanil Chaudhary, Manager Solutions and Services at Kovair Software Inc. Somanil has been associated with Kovair for more than 8 years. His key responsibilities are to provide on-site and offshore consulting services for complete ALM and Omnibus integration solution implementation. He also manages projects for Kovair products for all the customers. So without further delay, I introduce you all to our guest speaker. Over to you, Somanil.
Hello everybody, good afternoon. So I'm Somanil Chaudhary, Manager Solutions and Services, and today I will be presenting you a topic on synchronization and migration between ALM tools and the different value propositions of it. So in this webinar I'll explain the fundamentals, challenges, benefits of synchronization and migration in ALM environment. A short demonstration on synchronization and migration across multi-vendor tools will also be presented at the end. So the topics that I will be discussing in this session, first of all I'll discuss about synchronization and migration in the context of ALM, an overview. So under this particular topic, I'll discuss quite a few topics, like I'll start with what is ALM, the different challenges in an ALM scenario, why do we need sync and migrate across different tools, what is synchronization, migration, the different challenges that we face in the synchronization and migration, and also the benefits. Next, we'll go into the synchronization and migration, and we'll give an example of how you do synchronization migration by taking two tools as an example. Then we'll discuss about the different challenges that we come across while doing the synchronization and migration using HPQC and TFS as a scenario. Then we'll discuss about the solution, how we overcome these challenges in synchronizing and migrating artifacts from HPQC to TFS and vice versa. Then we'll discuss about the value addition, what are the benefits that you can get out of this solution. We'll discuss a brief about what is Kovair and what does it do, and finally a demonstration of the solution. So synchronization and migration in the context of the ALM. So the first question that comes into our mind is, what is ALM? So defining application lifecycle management, or popularly known as ALM, isn't easy. It's common to equate ALM with SDLC, but it is much more than just SDLC. In fact, it includes the entire time during which an organization is spending money on this asset, from the initial idea to the end of the application's life. As illustrated in the picture, ALM can be divided into three distinct areas: governance, development, and operations, showing each of these in its own horizontal line. Now, an application's life cycle begins with an idea. Once it is created, the next big event is deployment, where the application goes into production, and finally, when it is no longer has business value, the application reaches end of life and is removed from service. Now, these three aspects of ALM, that's governance, development, and operations, are tightly connected to one another. Every organization wants to do all these three aspects well, but it's not easy. The selection of right tools makes it easier. These tools should be not only be integrated horizontally, but vertically as well. For example, the project management tool should be connected to the development tools, which in turn should have connections to tools used for operations. So, what are the challenges that we face in the ALM scenario? Firstly, the disparate tools that are used in organization for different artifacts. So when you are using disparate, non-integrated tools in organization, it leads to several challenges in terms of data visibility, traceability, process automation, and cross-tool reporting. Next, if the relations between the artifacts in different tools are not maintained across the lifecycle stages, it may lead to process inefficiency, repeated manual tasks, unwanted human errors, productivity loss, and finally, delivery delays. Thirdly, the changes in one artifact do not get reflected automatically in other tools being used by other stakeholders. So while working with disjoint tools that are not integrated to one another, the changes made to one artifact in one tool doesn't get automatically reflected to other tools that are being used by the different stakeholders in the organization. So this is a big challenge. Fourthly, there is no aggregation and consolidated reporting from different artifacts stored in different tools. So generating consolidated reports, performance metrics across the tool artifacts is not possible if the tools are not integrated and the artifacts managed in each of these tools are not synchronized. And finally, no collaboration, groups working in isolation, problems detected in later life cycle have extensive impact. So here what's meant is that when teams are working in isolation, often end up producing faulty results, and these are detected much later in the development stage. These costly last-minute surprises can have really extensive impact on the different SLAs that are being calculated by the organization. So discussing about the challenges, now let's come to the question, why do we need synchronization and migration across ALM tools? So firstly, it's the data visibility across the tools. We want to see the data of one tool to be displayed in another tool. We also call it data plumbing. Secondly, we can create traceability between the objects in different tools so that when one object in one tool gets changed, we will be able to know what are the impacts being raised on other objects in other tools. So it is actually creating a change management and impact analysis across different tools. Thirdly, with integration in place, we would also be able to define process automation across tools for the whole life cycle. We use different tools that have their own workflow. But what about that workflow that cuts across the tool boundaries and creates a whole life cycle process? So we should be able to do that when we integrate different tools. And lastly, but not least, integration helps us to produce different kinds of reports, matrix, KPIs, dashboards out of the data coming from different tools. Due to the relationships between the objects in different tools, we can create such matrix and reports, which would have been otherwise impossible to derive from a single tool. So, understanding the needs, why do we need synchronization and migration across the different ALM tools? Now, the next big question comes up in our mind is, what is synchronization? So synchronization is the process of establishing consistency among data from a source tool to a target tool and vice versa, and also the continuous harmonization of the data over time between the tools that are involved in the data synchronization process. So let's take the following scenario. So here you can see that the two tools that are involved, tool A and tool B. Engineering team uses tool A. QA team is using tool B for managing their test cases. Now, both engineering and QA team wants to stay with their own tools. But like to have visibility on the respective artifacts like the requirements, the tests, the defects, as well as for the management reporting purpose as well. So this is a typical example of synchronization, a bidirectional synchronization between two tools that are involved in the testing and the engineering phase. Now, next comes the challenges that we often face while doing synchronization. The first one, the data formats complexity. So, organizations implement numerous tools for different vendors. The data formats vary from one tool to the other, which results not only in building a simple interface between the source and the target tools, but also in a need to transform the data while passing them to the target application. The data formats, of course, vary from proprietary formats to plain text to XML. Next, real-timeness. Today's organization needs real-time updation. Now, the main challenge over here is to work with such applications which do not provide any API to identify the changes. In such cases, performance may be the limiting factor. Thirdly, the security. So different tools have different policies to enforce data security. Even though it is maintained correctly in the source tool, the same security must be enforced on the target tool as well to prevent any potential misuse of the information. Fourthly, the data quality. So maintaining data in one tool and sharing with other tools is best practice in managing and improving data quality. This prevents inconsistencies in the data caused by updating the same data in the target tool. And finally, the performance. So in case of large data, each of the steps involved during synchronization, like the data extraction from the source tool, the data transformation, data transfer to target tool, data load on the target tool, may have impact performance. Therefore, the synchronization needs to be carefully planned to avoid any negative impact during peak processing hours. Next, what is migration? So data migration is the process of transferring data from one tool to another while the organization thinks of replacing the source tool for various reasons. Data migration can be achieved manually or programmatically. Now, there are three main options to accomplish data migration. First, merge the systems from the two companies into a brand new one. Second, migrate one of the systems to the other one. And third, leave the systems as they are but create a common view on top of them. Now let's take up this following scenario. So here, the engineering team is using tool B and the QA team is using tool A, but the QA team wants to move from their tool A environment and wants to do their work in tool B. Now, the QA team wants to use tool B's features and functionalities to execute their automation scripting as well. So this is an example of a one-way migration and replacing tool A with tool B. Now comes the challenges. So the first challenge is storage migration. So the challenge would be to handle application attachments and ASCII and UTF file formats, how they are migrated to the destination tool. Next is data migration. So the challenge over here would be to handle unmatched data types like the number, date, and vendor-specific proprietary formats. Third, security. So here the challenge would be during the migration to be compliant with the enforced data governance policy with the target application system. Fourth, the data quality, to maintain the data integrity and consistency as the data is migrated to the destination tool. And fourth, the data volume. So during the migration, another challenge would be the volume of data throughput and also the migration team needs to plan that what would be the final cutover that they would require to make the complete migration successfully. Now comes the benefits of a synchronization and migration. The first one, gaining greater insight. So once you synchronize or migrate to systems, so it becomes easier for you to answer the questions like what's the quality of the current release that you're working on, or what's the part of it is not stable yet, what are the corrective actions needed to make that part stable and all. So you get greater insight into the artifacts that are getting managed across the lifecycle. Next, overcoming the challenges for globally distributed development. So how do you synchronize your stakeholders' activities such that the developers in India start development after the requirements are designed in US, and testers in China begin testing immediately after development is complete? So that is a benefit that you derive out of the synchronization and the migration model once you have a global distributed team working across the globe. Third one, enabling collaboration between different stakeholders. So you are now in a position to answer the question like, how do I see my tasks and work items from within my tool, update my progress, status, and finally, how and when we can complete those. So migration or synchronization gives the answer to this question. The fifth one, improve quality with automated data sync and migration. So shorter development cycles and quicker software delivery decreases the interstage transition time. So that's how you can improve quality. Next, collect actionable metrics and intelligence. So you can now in a position, once you have synchronized two tools and you are bringing the data, you're bringing the artifacts across two different tools, getting into a centralized position. Now you are in the position to derive metrics like the reward percentage, the defect delivery, the defect distribute, the defect density, delivered defect density, or the project health amount. And also, one of the most advantages, the benefit of migration is now you get to use only one particular system, and now you can have a low cost of maintenance and you can have a single unified process to manage in a particular tool. So talking about the benefits, the challenges, now come to the point where we take up a particular example with two tools. So tools from two vendors we are considering in this particular example, HP and Microsoft. So for today's example, we have selected these two tools to discuss the specific challenge scenarios in context with these tools and how we can address those. HP Quality Center, so it's a popular tool for quality management used during software development. And Microsoft Team Foundation Server, so it's a complete ALM product combined with the Microsoft Test Manager, popularly known as MTM, and provides an alternate solution. Sorry. So, a lack of data visibility with other tools. So the lack of data visibility with other tools. So over here, manual intervention is required. So though HPQC allow managers to manage requirements, but if managers want to work with Word documents or some tools of their own choice, then the testers enter the requirements in HPQC, and someone needs to sync between the product documents and HPQC. So there's a big problem in the lack of data visibility with other tools. Secondly, unable to establish the traceability relationships with other ALM artifacts. So let's say the defects being managed from HPQC cannot be linked to the chain sets or the code files that the developers are working on from Eclipse or Visual Studio. Thirdly, it's not a popular tool for the developers as it doesn't have an IDE. Fourthly, doesn't have strong reporting capabilities. You need to have scripting, you need to have Visual Basic scripting to do complex reporting in HPQC. And finally, the tool is pretty expensive. Now, why to TFS? So first of all, it's a single platform for all teams, and collaboration and integration is pretty easy. So TFS is a good example of one platform for the entire team. Now, when the entire team works on the same single platform, collaboration, integration, and report generation becomes very easy and fluent. Secondly, TFS has tools for requirements management, design, development, and of course testing. Now, since all are available on the single platform, it is easy to derive complete traceability across the different lifecycle artifacts. Thirdly, it's a highly preferred tool for the development community, having its own IDE. So having its own IDE and source control management system, it's quite a perfect tool for the developers. And fourthly, the Microsoft Test Manager within TFS is a complete suite for testing, for doing manual, automated, and load testing as well. So it actually bridges the gap for the testers who are actually found to be working in silos. So talking about the general perceptions of HPQC and the capabilities of TFS 2013, and to move on, now the next question is, what are the different challenges that might come in migrating or synchronizing the HPQC artifacts to TFS work items? So we have come up with two different scenarios. So in scenario one, what we are discussing is, let's say the engineering team is working in TFS and they are using it for their own development environment and checking the files into the system. Now, the QA team were actually using HPQC are now split across, and a particular group wants to use HPQC and another group wants to move on to TFS and TM. So migration of these different artifacts like the requirements, test cases, and defects cannot be done overnight, and both the tools need to coexist for certain transition time. So it would be migration as well as a bidirectional synchronization between these two different tools. And how do we address this particular scenario? So I would come into the solution later when I discuss about how we address this particular challenge and convert it, and through a solution we give a proposition of doing this migration as well as synchronization through a single. Now, talking about the second scenario here is the engineering team is working in TFS, and the QA team who are using HPQC wants to move to TFS and wants to start using MTM, and they want to do it overnight. Now, additionally, the QA team, even after moving on to MTM, wants to use QTP for automation scripting. So this would be a one-way migration, as well as QTP scripts are to be executed from within the MTM environment. So how do we address this scenario as well? So now let's get on to the solution for addressing these two scenarios. So what are the features that we are using Kovair Omnibus to address this particular two problem scenarios? So through this particular solution, the features that we are offering is, first one is a complete support for call to tests. So it is a method by which a test case can be reused by using it as a state, as a design step in another test case. Next, mapping of QC requirements folder structure to TFS area path for requirement tracking. So in HPQC, requirements can be arranged in specific folders depending upon the business need. Now in TFS, it doesn't have any such structured hierarchy. So here, area path is an attribute where one can put the folder paths from HPQC to arrange the data as per the field value. Thirdly, mapping of QC releases and cycles to TFS iterations. So in HPQC, requirements can be segregated on the basis of releases and cycles within it. So this facilitates the user to identify the list of requirements within a release or in a cycle within it. So in TFS, those releases and cycles can be mapped with iterations, which will provide the user the same functionality required. The fourth one, migration of QC design steps with parameters and default values. So Kovair Omnibus has the capability to transfer parameterized design steps. So in QC, you can define design steps with parameters. And so Kovair Omnibus has the capability to transfer the parameterized design steps and the default values provided for each of the parameters right to TFS. Next, the bidirectional synchronization of requirements, defects, and other artifacts along with their interrelationships. So once you have migrated the artifacts from QC to TFS, then you are capable enough of doing a bidirectional synchronization, like you modify a particular requirement in QC and that gets reflected in HP, then TFS. You modify a test case in TFS, that also is reflected, the modification even is reflected back in HPQC. Along with, if you set up a traceability link with other artifacts as well, that can also be synchronized bidirectional between these two tools. Next, support for migration of history data. So this is very important, migration of history data. So with respect to a defect or a requirement, let's say till the date before you are going for this migration, there has been a lot of history, change history or audit trail that has been entered with respect to a defect or a requirement. So this migration solution is capable enough to transfer the history data with respect to those requirements and defects while these are migrated from HPQC to TFS, along with the contents of RTF fields, along the attachments that are attached to requirements or tests or defects. And finally, it's a 100% web-based interface, and you do not have to write a single line of code to set up all the different integration rules to synchronize or migrate it. So today the condition is to transfer only the higher priority defects, and then you can very well do it. You do not have to change your code to change your business logic. So it can be done from the web interface. So Kovair connects and acts as the synchronization or the migration solution between these two tools. And in the process provides you all these features that has been discussed in this particular list. Now comes the solution to scenario 1. So I have been talking about Kovair Omnibus. So what is actually it is? So Kovair Omnibus is based on an enterprise service bus architecture that requires only one connector per tool, thereby making the integration environment readily scalable. It is capable of integrating tools irrespective of their vendors and platforms. You can create adapters using the available open APIs, and the integration rules, unlike point-to-point integrations, are not hard-coded, and they are open for you to define your own business logic. So now we address scenario 1 and provide you the solution. So here you can see the first step, we do an initial migration of data from HPQC to TFS. Next, the bidirectional synchronization of artifacts between these two systems are automatically established. You modify a test in TFS, that gets reflected in HPQC and vice versa. The next, Kovair Omnibus provides an interface to configure and migrate data between these two systems. So you can actually define the business logic. Fourthly, it makes sure that the items remain synchronized even after the migration is done. So that's the way you get the solution of a two-way synchronization between the artifacts that are first migrated and then they are kept in synchronization, a bidirectional synchronization between HPQC and TFS. Next comes the solution to scenario 2. So over here, artifacts like requirements, test cases, and defects are migrated from HPQC to TFS. The QTP scripts associated with the QC test cases are also migrated from QC to TFS as generic tests. And once they are moved on to TFS, these automated scripts can directly be executed from MTM using QTP. So you do not need QC in between to execute these automated scripts. So that's an example, that's a solution that we provide for this one-way migration using Kovair Omnibus. And as I was talking about the connectors of the adapters, so here's the QC adapter and here's the TFS adapter that actually communicates with the Kovair Omnibus engine in extracting the data from the source to the destination tool and vice versa. Now what's the value addition of this particular solution? So the benefits that have been derived from the solution is once you have the TFS, so it has created unified TFS repository for all ALM assets like the requirements, development, test, build, and others. Full collaboration between the development and QA teams, centralized reporting from TFS. So being a single platform for managing all these ALM artifacts, collaboration among the different teams working on it becomes smooth and generating reports from the centralized repository no more takes longer time. Then you have easy and flexible configuration. So as I already mentioned, the integration rules are not hard-coded in the Omnibus engine or in any of the tools adapters. So configuration of the synchronization and the migration rules can be done by the users from the front end itself without writing a single line of code. Next, execution of QTP scripts that are linked with the test cases from MGM. So using the Kovair migration solution through Omnibus, QTP test scripts along with the important information like the test name, the storage, the test type, all are migrated to TFS along with the HP test cases. Now once these are saved in TFS, you can directly execute these scripts from the TFS MGM environment. Next, you have once the test cases inside the TFS, so MGM has its support for this manual and automated and load testing. You can directly view the QTP results from MGM, and being a single platform for multiple tools, so the user's productivity increases as you do not need to run into different tools to gather artifacts, to derive new reports, or do all this varied traceability stuff. And finally, getting into a single tool obviously reduces the cost of maintenance of those tools. Now, a little bit about what we do. So, talking about Kovair. So, Kovair provides a platform and services to integrate multi-vendor tools for unified software development environment. So, it provides an integrated view of all the ALM tools put together, a central repository where the artifacts from all these connected tools can be stored, which can later be used for viewing the end-to-end traceability, tracking, and reporting. Secondly, Kovair provides an integration technology, which we call the Kovair Omnibus platform. So it's built ground up on an SOA-based enterprise service bus architecture, and we have connectors for most of the major tools in the market. So this list is actually growing based on the requests that we receive from our customers for creating adapters for different tools. Next, talking about the Omnibus architecture at a very high level. So in the middle, you can see this particular cylindrical bus structure. This is the central Omnibus processing engine. And these are the adapters which connects the tools to the Omnibus engine. Now once a tool is plugged into the platform through its adapter, immediately it is capable of establishing the communication with the rest of the tools that are connected to the platform. As I already mentioned, the integration rules are configured from the front end, and it's used and it's been configured using this Kovair application through a web browser, which is accessible from anywhere. The configurations are stored in this Kovair database, where each of the adapters has its own local databases. So Kovair Omnibus is having adapters for most of the major tools in the market, and this particular slide shows that what are the different adapters that we have for the different tools. So talking about the requirements management tools, we have adapters for Requisite Pro, RRC, Doors, JAMA. For the configuration management, you can see a long list of tools. Test management, we have adapters for TestLink, HPQC, RTL, and all. So not only, So not only the SDLC tools, but we have adapters for tools belonging to different domains as well. For example, we have Salesforce from the CRM domain. We have Remedy and ServiceNow, ITSM domain. For the PPM domain, we have Clarity, and for the content management, we have SharePoint as well. So with that, I conclude my presentation, and now I will move you on to a product demonstration which is already recorded in YouTube. I'll share the link with you as well. So just give me a second. Let me start the video.
As well. This requirement has a link defect, validation error at registration page. To verify this requirement, there are two test cases. First, we have test for registration page, a simple manual test case. And second, we have the Omnibus login test, which is an automated test case. You can see the type of test is indicated by these icons. On this next requirement, Omnibus entity mapping functionality, note that we have an attached text file, mtmdetails.txt. This requirement also has a link defect, JS error at field mapping page. For this requirement, there is a single test case named Project Selection, a simple manual test case. Next, we move into the testing area to examine some of test cases. The test plan consists of 3 tests. As we've seen previously, the Omnibus login test case and the test for registration page are linked to our first requirement. The project selection test is linked to our second requirement. You'll notice our test case, test for registration page, has 3 steps. The first test is a test for general info. Next, we have a test case, our project selection test case, which has been nested and used as a test step here. In QC terminology, this is referred to as a call to test. The third test step is called test for security parameters. Notice that the first and third steps are parameterized tests, as indicated by the parameter names encased within triple sets of angular brackets. If we take a look at the Parameters tab, we can see the values that will be used for the test. The green check marks indicate that the parameters are currently in use in one or more design steps. Next, we move to the project selection test and see that it has only a single step, select default project. This is a simple manual test. Last, our Omnibus login test is an automated test with a QTP test script associated with it, as you can see here. We've just seen our requirements with their associated tests, both manual and automated, defects and attachments in Quality Center. Next, we move into Kovair to show you how migration is done. Here we are in the Kovair application, and I'm currently logged in as an administrative user with the necessary permissions to do the migration. The synchronization option is available from the tool registration page in the Omnibus setup area and is used for migration. I'll select the QC registration, right-click to bring up the context menu, and select the Synchronize option. Here's the tool synchronization page. In the synchronization list, we have already configured a synchronization named QC to TFS migration. You can save your configurations for later use. Alternatively, we could have simply given a name to begin creating a new synchronization. Instance 1, the source instance, is automatically set to Quality Center since we began the synchronization from that tool. We have selected the target instance, TFS. The project selection choices available are set based on the project or projects chosen for the tool registration. There may be more than one available, but in this case, there's only a single project in each tool, so they are selected automatically. Next, we see the base entities for the synchronization, in this case requirements. Next, we come to entity mapping, which controls how data is mapped from the fields in one tool to the fields in another. Since there is only one mapping that has been created for requirements between these two tools, it's automatically selected. Next, we move to the item selection criteria. Here, we are able to define conditions to control which data is to be synchronized. Items matching the conditions specified here will be included. In the field drop-down, you can select any of the various fields in Quality Center, pick a condition, and provide a value. For the purpose of our demonstration, we set the condition requirement ID is greater than or equal to 9, which matches our requirement ID in use, numbers 9 and 10. It's also possible to use multiple conditions, as well as set conditions in the target instance. Now that we have completed migration, we move into TFS Server to see the results. Here in the MTM interface, we can see the Omnibus test plan. I'll open up the test plan. Here we see the Omnibus folder, the 2 requirements it contains, and the 3 tests contained in our test plan. Selecting the individual requirements shows the linked test cases, 2 for our first requirement, Omnibus registration page, and 1 for our second requirement, Omnibus entity mapping functionality. Opening our first test case, test for registration page, we can see the 3 individual steps it contains. You can see here are 3 test steps which have been migrated from QC, along with their parameters denoted by the @ symbols. The parameter values are listed below, a web service URL and server name. For our second test step, we had used a call to test in QC. The equivalent concept of reusing a test case as a step is referred to as a shared step in MTM. Opening up the shared step reveals the individual testing steps contained within it. Here is the Omnibus login test automated test. Under the associated automation area, you find a few attributes: the test name, storage area, and the type of test. We now head over to TFS 2013. Clicking on the All Requirements query brings up our two requirements from QC. Again, from here we can see the two test cases that verify this requirement. Clicking on the All Links tab, we can also see the related bug. Notice in the classification area, we have the full path to the Omnibus folder. The area path consists of the project, migration, the artifact type, requirements, and the folder for requirements belonging to Omnibus. Here in the history for the requirement, we can see that an audit trail is being maintained of every change to the requirement, including by whom and when it was altered. Similarly, in our second requirement, we have the late test case. In the Attachments tab, we can see our file from QC, mtmdetails.txt, which we can open from here and view its content. I'll run the All Test Case query so that you can see the test cases are also available from here within TFS, similar to what we saw in the MTM interface. Now it's time for us to start a build. Here is a build definition which we have previously created. I'll queue a new build based on this and assign it a high priority. Here you can see our newly started build as its status is updated. It's running and is now complete. Once the build has been finished, the automated Omnibus login test begins to run in QTP. You'll see the Kovair login page opened, credentials supplied, and automatic log out. Here we can see the summary for the build. The summary is updated with the results of our test run. So far, we've seen the test run in QTP with the results being passed back into TFS. Next, we run this test from within the MTM environment. I'll set the test to be run against the latest build here. Now that that's set, we head over to the testing center to run the Omnibus login test. As we run the automated test, you'll see QTP open and the same test repeated, logging into the Kovair application and out once again. Now that the test is complete, I'll refresh and you can see the status of the test has been changed to passed. Let's check out the results view. You can see our test result has an attachment, a batch file called QTP result. Opening this provides yet another way to view the results. Here's the testing status as presented in the Run Results viewer. I'll create a new test case in MTM, which will flow into QC via the Kovair Omnibus. This title will help indicate where the test is from. I'll also create a couple of testing steps and save the test. Back in QC, I'll refresh the view. And you can see our test case and steps have arrived from MTM. I hope you've enjoyed this demo. To learn more about Kovair solutions, please visit us at kovair.com.
Okay, so thank you for watching this presentation. And that concludes my presentation for the today's session. And if you have any questions, I can take up those over here. So let me see what are the different questions that we have. So what's the server hardware and software requirements for Kovair Omnibus? So we have a detailed document on what are the different hardware and software specifications. So if you kindly send us your email, we can send it across to you. So kindly send us your email at sales.kovair.com, and we can email it to you regarding the hardware and the software requirements. Okay, so that was it. I'm having a hard time in getting the questions, so just bear with me. Can we install ALM on Windows 7 32-bit and which other OS? Yes, it has to be on Windows 2008 to Windows 2008 Act 2. It can you can install it on Windows 7 as well. So send us your email, we'll send you across the detailed hardware and the software specification requirements. Next question. Does the data include refer to the code design, use cases, test data, etc.? Yes, absolutely. So so data represents the requirements, the tests, the defects, the genset, the code files, not only the artifacts but also the attachments, the change history, and the RTF content of any of the fields as well. So how can we use Omnibus in our day-to-day activities? So if you are having a set of tools in your organization, and the different groups are working in each of these tools, but these tools are working as silos, and a lot of manual intervention is required in getting the artifacts from one tool to the other, export it from one system, import it to another, and then the second group starts working on it. Based on that, certain people needs to be notified when things are not in proper place. So when all these things happen, Kovair Omnibus can sit in between as the enterprise service bus, as the integration bus, and once all the adapters to each of these tools are hooked up to this particular platform, then it is an automated flow that whenever a particular artifact is being added or modified in any of the tools, based on the event action mechanism that you define from the front end, the data flows to the target tool. So that's a typical example that you can use it. So let me see the next question. So here, what is KPI? So KPI is key performance indicators, which are normally used for measuring different metrics and performance, and normally generated out of the data for presenting it to the management for reporting purposes. So that was another question. Next question. Can we install ALM on Windows 7, 32-bit that I've already answered, and which other OS? It's Kovair Omnibus and ALM works on the Windows platform only, so you cannot install it. We are very much into Microsoft, so it cannot run on any other platform or any other OS. So that's all with respect to all the questions that I'm having. So I'm waiting for any other questions that might arrive. But additionally, if you have any other questions, so you can contact us at sales@kovair.com. You can get to our website www.kovair.com. You will get a lot of information on this particular topic over there. You can go into the press release, and you can go into our resources section. So a lot of relevant materials, white papers and data sheets will be available to you that you can download and read. Okay. So with that, I conclude my presentation. Thank you everybody for your time.
Well, thank you so much, Sominal, for answering all the questions. That was a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the session would be available on techgeek.com by tomorrow. Thank you all. Have a great evening.
Thank you.